Hi everyone, just a quick video on starter motors and what's inside them and how they operate. So what I've got in front of me here is a typical pre-engaged starter motor that you'd find on any modern internal combustion engine. Easy to identify what type it is because you've got the cylinder for the DC motor at the bottom and then you've got a cylinder for the starter motor solenoid above it. So what happens when you start the car? So when you turn the key or push the button in the car, you complete an electronic circuit. That sends a small amount of current down this extremely thin wire here into the starter motor solenoid. The amount of current it supplies is just enough to create an electromagnetic field in here. So if I was to chop this in half, you'd find there's just a coil winding all the way around there with thousands of turns. So that creates an electromagnetic field. You can see inside there, right in the middle, there's a little plunger. So what happens is, during normal driving conditions or when the car's not on, this spring acts as a hold-off spring and it stops this plunger acting on the other one inside there. When you turn the key in the car, it creates an electromagnetic field, as I mentioned, and it pulls this plunger in and overcomes the spring. That hits the contact at the back of the starter motor, and that completes a new circuit. So with that pressed in, and a complete circuit here, that then allows high current 12-volt battery power coming down through the back of the starter motor solenoid, and then from this contact it leaves, goes through the little gap there in the casing, and drops into the DC 12-volt motor. So that's the solenoid there. So 12-volt DC starter motor, obviously we've got a rear casing, and then the first thing it comes down to is here, which is your carbon brush pack. Normally made of copper with some carbon in there, and there should be 4 of those. They're extremely soft metal, so normally when you get motors failing, it is these brushes that tend to wear down and lose electronic connection. So with the current entering the brush pack, what happens is these brushes electronically connect to the end of this component here. So this is the commutator plate, and this commutator plate here has lots and lots of different connections on it. So I'm just going to remove this from here because it's quite a lot of magnetic strength. Every time a brush hits there, one of these contacts, it creates a complete circuit and it powers up one of these coils that goes round. In the outside of the casing, on the inside, you'll see there's a set of magnets, normally arranged north, south, north, south, north, south, and obviously we've got a set of magnets here. So it creates an electromagnetic field. And what happens is every time it runs over one of these, they repel each other. So it creates an electromagnetic field, it reacts to the ones on the outside of the casing, or in the casing itself, and it moves it over. And then it moves on to another contact, and it moves it over again, using electromagnetism to move the motor, and it's self-perpetuating. So the faster it goes and the more contacts it hits, the faster the motor starts moving, and it spins extremely fast, obviously because of magnetic repulsion. So what we've got here then is the motor spinning itself. On the other end, you'll obviously see we've got the pinion gear here. This is what locks onto the flywheel to start the car, and the reason it's called pre-engaged is because this pinion gear attaches to the flywheel before the motor starts turning. Previous starter motor designs would have it so it would smash straight into the flywheel, and that would damage both the starter motor and the flywheel itself. So the pre-engaged one came along to reduce that wear. So why it's called pre-engaged is while all this is happening on the back end and the power's being sent down the back of the motor here, we've also got this this arm here which attaches to the plunger. So when the starter motor coil activates, it pulls a plunger in, but it also rotates this arm and flicks it out. So that would flick out here. So it pushes the starter motor pinion out at the same time that it activates the high current circuit to then power the motor. So it's pre-engaging onto the flywheel before the motor starts spinning. That reduces damage and obviously increases the life expectancy of the starter motor and the flywheel as well. So that's roughly what happens inside a starter motor. I hope it makes sense, and I'll see you on the next one.